Answer one of the very interesting question: why our eyes can't see inside solid? And the answer will be given in terms of 1D monoatomic lattice vibration. The dispersion relation for monoatomic lattice vibration can be written as omega equals to 2 Vs by A sin Ka by 2, where Vs is the velocity of sound or velocity of phonon waves inside a solid. How I can reach this equation? I'll tell in very brief way. This one is a monoatomic lattice chain, and this is the equilibrium state, where these are the atoms and the interatomic distance is A. So this is a monoatomic lattice chain, and this is the equilibrium state. These are the atoms. This is a atom. This one is atom, and I have assumed this one is as the reference atom, or this or nth atom. So this will be n plus 1th atom, and this is n plus 2th atom, and this one is n minus 1th atom. This is the state of equilibrium. Now, if the atoms get displaced by any means, let's say, and their displacement is also not equal. See, this atom, the displacement is maximum for this atom, and for this the displacement has decreased. It has more decrease in this side. So the displacement, that is un plus 2 for the n plus 2th atom, that is greater than the displacement u of n plus 1th atom. So u plus n plus 1, and so, right? So counting the displacement, and as I have taken this one, the nth atom, as reference atom, let's write the equation of motion for this atom. So what will be equation of motion for this nth atom? Let's see. Suppose this one is an atom, and this is a spring. Spring means basically this spring represents the bond between these atoms. It may be a covalent bond or any type of bond. So it basically represents the bond between two atoms. Okay, now let's say this is the equilibrium state, that is two atoms are in equilibrium state, and their bond or the spring is also in equilibrium. Now when the spring gets elongated, it will try to get back to in its equilibrium state. That is, it will pull this atom in this direction, and the spring will pull this atom in this direction also, right? So similarly, for this nth atom, what will happen? This nth atom, this spring, it will pull this nth atom in this direction, and this spring, it will pull this atom in this direction. So let's say this force is F1 and this force is F2. So what will be F1 and F2? F1 equals to, so F1 is in the direction of ultimate displacement, so it will be plus, so F1 will be beta is spring constant, so beta into, now u, the what is the displacement of the spring? Simply un plus 1 minus un. So F1 will be un plus 1 minus un, and F2 is in the opposite direction of the ultimate displacement. It will be minus beta into un is greater than u, because displacement in this side is larger. So it will be un minus, this is un minus 1, un minus 1. So what will be the total force F vector? That will be F1 plus F2. So it will be beta un plus 1 minus un, that is minus 2 un minus a plus un minus 1. That will be the total displacement. So equation of motion for the, so I have written that this equation of motion for this nth atom. So it will be m d2 un dt2 equals to beta un plus 1 minus 2 un plus un minus 1. Now I can easily solve this equation of motion by just simply we solve the way. So un will be u0, which is amplitude of oscillation, e to the power I omega t minus k na, un minus 1 will be u0 e to the power I omega t minus k n minus 1 into a, and what will be u n plus 1, that will be u0 e to the power I omega t minus k n plus 1 into a. You just put these three value in this equation and the final result will be m omega square equals to 2 beta into 1 minus cos kn. This is called the dispersion relation for phonons in 1D monoatomic lattice. This is a very important relation. So m omega square equals to twice beta 1 minus cos k. This is the dispersion relation for phonons in 1D monoatomic lattice. And if we little bit manipulate this equation, we can reach omega equal to, so m omega square, so omega will be root over of twice beta by m, which is known as omega m. So omega m and the rest of the term will be there. So omega will be finally omega m into 1 minus cos ka. And again more manipulation, finally our equation will take this form. Omega will be omega m, 1 minus cos theta is 2 sin square theta by 2 ka by 2. So it will be, okay, there is a little mistake. So omega equals to root over twice beta by m and root of this quantity also. So omega will be omega m root over 1 minus cos a, and 1 minus cos ka will be 2 sin square ka by 2. It will finally take the form omega m. I will use modulus sin ka by 2. Why I have used modulus? Because, and I have excluded the plus minus sign here because frequency can't be negative, it is always positive, so no need to write plus minus, and that's why I have take a mod, because again frequency can't be negative. Where this omega m, this is equals to root over 4 beta by m. This is not omega m, it will be omega m when this 1 minus it will be, okay, let me write this as omega square. This will be simply twice beta by m, and let's remove the root sign from here. Now things are okay, and it will be omega square equal to root twice beta by m, here also twice beta by m, 1 minus cos ka. This will be twice sin square ka by 2. This 2 into 2, that will be 4 beta by m, that will be omega m. So what we have finally got, omega equals to omega m sin ka by 2, and this omega m equals to root over 4 beta by m. Further manipulation of this equation I can get and use this equation, Young modulus equals to beta into a, and one more relation you have to use, that is Vs, velocity of sound inside solid, will be Young modulus by rho, where rho is the mass density, equal to m by m. Using all this relation, finally I can get omega equals to this one, 2 Vs by a sin ka by 2. So let's write this in blue color. So the final relation is becoming omega equals to twice Vs by a modulus of sin ka by 2. On basis of this equation, I will give you the answer why our eyes can't see inside solid. Now let's draw the graph omega versus k. So we will plot omega here, and this is k. So at k equals to 0, sin 0, so omega will be 0, right? And at k equals to, let k by 2, at k by 2 equal to pi by 2, what will be value of k? K will be pi by a. So this will be pi by a, and at this value omega will be twice Vs by a, that is omega will be maximum. So that will be the maximum value of omega, and then k by 2 equal to simply pi, so sin pi is 0. So at k equal to 2 pi by a, this will be 0. So at 2 pi by a, omega is becoming 0. The same thing in the negative side also. At minus pi by a, this will be maximum, and minus 2 pi by a, it will be 0. And this is omega m, that is maximum value of omega, and that will be omega m equal to, when k by 2 equal to what, k by 2 equal to pi by 2, that will be omega m is twice Vs by a. Clear? Now if you see, I have plot k in this axis, right? This dispersion relation, it will vary depending on this k value. When case 1, when k tends to 0, k tends to 0 means it is long wavelength region. It is long wavelength region. Why it is long wavelength? Because k equals to 2 pi by lambda. When k is 0, that is k is very low value, lambda will be high value, so it is long wavelength region, and k tends to 0 is this region. So at this region, k sin k a by 2 is approximately equals to, when theta is very what I should say, when theta is very less, sin theta is theta, so it will be simply k by 2. So the dispersion relation, this dispersion relation becomes omega equals w, that omega equals 2 Vs by a into k a by 2, that is k Vs. So at k tends to 0 or long wavelength region, the dispersion relation looks like this, omega equals to Vs into k. Now, so what will be, let's look what will be group velocity and phase velocity. Let's take one more page. Group velocity and phase velocity. Phase velocity Vp equals to omega by k, that is Vs, and group velocity Vg will be d omega by dk, that will also be Vs. When the group velocity equals to phase velocity, that medium is known as non-dispersive medium. I can't tell here what is non-dispersive or dispersive medium, but if you are interested, just comment below. I'll make another video on dispersive and non-dispersive media. So at k tends to 0, the medium behaves as non-dispersive media because the phase velocity is equal to group velocity. Now let's look at case 2, when k is short wavelength region, that is k is large value, and that means short wavelength region. So the dispersion relation, it will not change, it will be just simply what is there, omega equals 2 Vs by a sin k a by 2. What will be phase velocity Vp? That will be omega by k. So I can write this as Vs, and 2 by a, I will write it as sin k by 2. 2 by a, with the along this k, it will be k a by 2. That will be the phase velocity. And group velocity Vg d omega dk, it will be simply Vs into cos k a by 2. So in this case, phase velocity and group velocity is different, so the medium is now dispersive media. Now we are very close to answer our question, why solid does not allow visible light to enter it, or why our eyes can't see inside the solid. Let's draw Vp and Vg, because this is very important. See, at k equals to 0, if you look, this is Vp relation, this is Vg relation. At k, when k tends to 0, Vp will be sin k by 2 by k by 2, limit k tends to 0, it is 1. So Vp will be Vs, and Vg will also be at k equals to 0 Vs. So they both will start from this portion. This is k, and this is k is 0 value. Now when k will be pi by a, because the next becomes pi by a, next k value, so this is pi by a, and then it will be 2 pi by a. In this side also pi by a, then it will be twice pi by a. So at k equals to pi by a, Vp will be k is pi by a, so that will be sine pi by a into a by 2, that is sine pi by 2 divided by Vp equal to Vs. K is pi by a, so pi by a into a by 2, pi by 2 it is 1, so it is 2 Vs by, so Vp will be twice Vs by pi. So at pi by a Vp will be 2 Vs by pi, so Vp will decrease, and at 2 pi by a Vp will be, if you put k is 2 pi by a, pi sin pi will be 0, so Vp will fall like this. Vp will fall like this, and this side also it will fall like this. But what about Vg? Vg at 0 is Vs, and at k equals to pi by a cos pi by 2 it will be 0, so Vg will be 0 here. And after pi by a, what will be Vg at 2 pi by a? It will be Vs cos pi, that is minus Vs. So Vg will go like this, so it will be minus Vs. Now if I say about group velocity and phase velocity, velocity after this pi by a, velocity is becoming negative. That means this wave will reflect back, because group velocity is never negative, so if it is negative it means the wave will reflect back. Alright, wave always travel in a group. It is never like a single wave is traveling inside a solid or inside any media. Just for example, light wave, so we see light, but that is not a single wave, right? There are, like for example, there are red color also, there are violet also, and in between red, violet there are green, orange, and lots of colors. So they all have different wavelengths, so that means that is a group of wave. So inside solid also a group of wave is travels, and that velocity is Vg, group velocity. And Vg negative means that wave is being reflected from the solid. That is what do I mean by a negative group velocity. Clear? So from this case, so let's take case 3, that is cutoff frequency. So what is the cutoff frequency? So inside solid, k equals to 0 to pi by a, this wave can travel. After pi by a, Vg is negative, that means wave is reflecting back. That means the limit is k equals to plus minus pi by a. So k equal to, basically limit is 0 to plus minus pi by a. So what will be lambda corresponding this plus minus pi by a? K is 2 pi by lambda, that will be plus minus pi by a, or I can omit this plus minus sign. So lambda value is becoming 2 pi by lambda equal to pi by a, so lambda will be twice of a. That is the minimum wavelength that can travel inside a solid. This is minimum wavelength, so no wave less than lambda equals to 2a travel inside a solid. Is no wave that is less than lambda equals to 2a will be able to travel inside the solid. So k equals to 0 to pi by a, wave with this k value will travel. That means lambda value will be 2 pi by a corresponding to this pi by a. And if you look at lambda equal to k equal to 2 pi by lambda, means lambda is 2 pi by k. If you put k equals to 0, lambda will be infinity. That means it may be lambda may be any higher value, but the lowest value is 2 pi by a. So any high value, but the lowest is 2 pi by a, that can travel inside the solid. So corresponding frequency we will look now. So this is the lambda equal to 2 pi by a minimum, it will be the minimum wavelength. Now let's answer our question. We are very close to it now. Let's say for any crystal the interatomic separation is 1.5 angstrom, and what will be the minimum wavelength lambda that can travel inside the solid? It must be 2a, that is 3 angstrom. And if velocity of sound inside that solid is 5000 meter per second, for example, then what will be the frequency? That will be Vs by lambda. So 5000 by lambda is 3 angstrom, 3 into 10 to the power minus 10 meter. So it will be simply 5 by 3 into 10 to the power 13 hertz. See, it is in the 10 to the power 13 range, and this frequency, it is of infrared. This is infrared frequency. Alright, so this is the minimum wavelength, means lambda is proportional to 1 by nu. So that is the maximum frequency that can travel inside the solid, that is 10 to the power 13 hertz. Now our visible range frequency is 10 to the power 15 hertz, which is greater than 10 to the power 13. That means solid won't allow it to enter. What will happen? Whenever it will try to enter the solid, the wave will simply reflect back. Just like this case here, the wave was reflecting back. So solid will not allow the visible frequency light to enter it. It will simply reflect back, and that answers your question.